Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is in this part 6 video from the chapter of Heron's formula. I will solve set 3 of 5 illustrative problems based on the concept of area and perimeter of triangles that I have discussed in part 3 video. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the first problem says that area of a right angled triangle is x and its perimeter is y. Then the length of the hypotenuse is, okay, so let's say this is the right angle triangle ABC. We have to find the hypotenuse. Okay, let's say the length of the arms or the perpendicular sides are A and B. Let's say not A and B, let's say x and y. So the hypotenuse as per the Pythagoras theorem will be square root of x square plus y square. Okay, area we know area will be equal to half into base and height. We can consider the two perpendicular arms as the base and height, so it will be xy by 2. Okay. Now no, let's say the hypotenuse will be the hypotenuse, since the perimeter is given as y, we can say the we cannot use y as the length of the arm because the perimeter is given as y. Okay, so let's say the length of the arms are, let's say PQ. So okay, so the perimeter is given as y, so the hypotenuse will be y minus p plus q. Y minus p plus q. Okay. Okay, so and then the area will be PQ. The area will be PQ by 2. PQ by 2. Okay. Okay. Now, so this implies that PQ is equal to, area is given as x. Area is given as x. So this will be x. So PQ is twice x. Okay. Okay. Now we know that the hypotenuse. Okay, so hypotenuse using the Pythagoras theorem, we must have p square plus q square should be equal to y minus p plus q square. Expanding the right hand side, it will be y square minus, if I expand p plus q whole square, it will be minus p square minus q square p square plus q square should be equal to y minus p plus q whole square. Okay. We have to find the hypotenuse, then the length of the hypotenuse. Okay. Length of the hypotenuse. Okay. No, I'm solving it incorrectly. Let's say the hypotenuse is it is, let's say, r. The length of the hypotenuse is r. Then we must have p square plus q square should be equal to this should be equal to r square. Okay, r square, hypotenuse. Okay. Mm, mm, this implies p square plus q square. We can say this is to be p plus q whole square minus twice pq. Using the identity, we know that p plus q whole square is p square plus q square minus plus twice 2pq. So then we can say that p square plus q square is equal to p plus q whole square minus 2pq. This is equal to r square. Okay. And now this implies, what is p plus q? P, we know that p plus q plus r is the perimeter which is given as y. So this implies that p plus q is equal to y minus r. So we can say p plus q is y minus r. So y minus r square minus 2pq. pq is twice x. So 2 into 2x is equal to r square. So this implies, if I expand p y minus r whole square, it will be y square plus r square minus 2yr. We have minus 4x is equal to r square. So this implies r square will cancel out from both the sides, LHS and RHS, and we have y square minus 2yr minus 4x is equal to 0. This implies 2yr is equal to y square minus 4x. So this implies r is the length of the hypotenuse that we have assumed. So r will be y square minus 4x divided by 2y. So y square minus 4x divided by 2y is the length of the hypotenuse. So the correct choice is A. A is the correct choice. Let's see the next problem. Question number 2. The perimeter of an isosceles right angle triangle having an area of A is. So in a isosceles right angle triangle, let's say this be an isosceles right angle triangle ABC. Let's say the length of the two equal sides, that is the arms, be A. Okay. Now the perimeter of an isosceles right angle triangle having an area A. So the area will be A will be equal to half into base and height. We can consider the two perpendicular arms to be the base and height. So this will be half into A into A. This is equal to A square by 2. So this implies that A square is equal to twice A. Also, applying the Pythagoras theorem, the length of the hypotenuse, that is AC, will be equal to square root of A square plus A square. This is equal to square root of 2A. Now square root of A, square root of 2 multiplied by A. Now from here we can say A square is twice A, so A will be equal to square root of twice A. So then the hypotenuse becomes square root of 2 multiplied by A, which is square root of 2 multiplied by A is square root of twice A. This becomes 2 into square root of A. So then perimeter P is equal to A plus twice square root of A. So this is twice A plus 2 into square root of A, and small a we know is square root of twice A. So this is 2 into square root of twice A plus 2 square root of A. This is equal to, if I take 2 square root of A common, I have square root of 2 plus 1. So 2 square root of A multiplied by square root of 2 plus 1 is the perimeter of the isosceles right angle triangle whose area is capital A. So the correct choice is B. B is the correct choice. If I am incorrectly solving any problem or applying concepts incorrectly or applying wrong concepts or doing any kind of silly mistake, then please feel free to let me know in the comment section. I will highly appreciate that, and if you have any kind of query or question regarding any concept I am applying, any steps, then also please let me know. I will do my best to assist your query. Let's see the next problem. Question number 3. A square and an equilateral triangle have equal perimeters. If the diagonal of the square is D, capital D, then the area of the triangle is square. Okay, so let's say this be the square. If the diagonal of the square is capital D, okay, so the diagonal is given to be capital D. Let's say the length of the sides of the squares are small a. Okay, and we have an equilateral triangle. Let's say the equilateral triangle be this. Let's say the length of each sides of the equilateral triangle be small b. Now the perimeters of the square and the triangles are equal. So what is the perimeter of the square? It is 4a. And what is the perimeter of the triangle? It is 3b. So it is given that perimeter of square and perimeter of the equilateral triangle are same. So P1 should be equal to P2. This implies 4a is equal to 3b. This implies B is equal to 4a by 3. Now what is small a? Small a we have assumed to be the length of each side of the square. Only the diagonal of the square is given. We know that each side of a square is equal to its diagonal divided by square root of 2. So this is 4 by 3 multiplied by d by square root of 2. This becomes, if I multiply, it is always convention to not keep rational numbers in the denominator. Always rationalize any irrational number. There should not be any irrational number in the denominator. Always try to rationalize that. So we see it is d by square root of 2. I will multiply numerator and the denominator with square root of 2. So this becomes then 2d square root of 2 divided by 3. Okay, this is b is small b, that is the length of the equilateral the length of each side of the equilateral triangle is 2d square root of 2 divided by 3. So then the area of the triangle, equilateral triangle, area for an equilateral triangle is conventionally denoted with this triangle or delta symbol. So area will be, we know for an equilateral triangle the area is square root of 3 divided by 4 multiplied by the square of the length of each side, and we see that b is, so it will be b square. So this is equal to square root of 3 divided by 4 multiplied by 2d square root of 2 divided by 3 whole square. So this is equal to square root of 3 divided by 4 multiplied by 4d square multiplied by 2 divided by 9. This is equal to 4 cancels out. This is equal to 2 square root of 3 divided by 9 multiplied by d square. So the area of the triangle should be 2 square root of 3 by 9 multiplied by d square. So the correct choice is B. B is the correct choice. Let's see the next problem. Question number 4. The area of a triangle is 28 centimeter square. If one of its perpendicular side exceeds the other, I think the triangle is right angle triangle, because it is saying that if one of its perpendicular side exceeds the other by 10 centimeter, then the length of the longest of the perpendicular is, then the length of the longest of the perpendicular is. Okay, let's see. This be the right angle triangle ABC. Let's say the shorter perpendicular side, the length of the shorter perpendicular side be x centimeter. I'm not writing the units, I hope you will understand. Then the length of the longer perpendicular side will be x plus 10, since it is given if one of its perpendicular side exceeds the other by 10 centimeter. Okay. So area then will be equal to half into the product of the length of the perpendicular sides, which is x multiplied by x plus 10. This is given to be 28. So this implies we have x into x plus 10 is equal to 28 multiplied by 2, which is 56. So this implies if I expand the left hand side, it is x square plus 10x, and if I bring the 56 to the left hand side, it will be minus 56 equals to 0. So this is a quadratic equation in x. I hope you have already done quadratic equation. Now, how do you solve a quadratic equation? One way is to by factorization method. So this implies, can we factor 10x? 56. What are the factors of 56? 7, 8, no. 28, 2, no. 14, 4, yes. 14, 4 will work out, yes. So this is x square plus 14x minus 4x minus 56 is equal to 0. This implies x multiplied by x plus 14 minus 4 x plus 14 is equal to 0. This implies x plus 14 multiplied by x minus 4 is equal to 0. So from this equation, the x plus 14 multiplied by x minus 4 is equal to 0. We can have two solutions of x. So either x, this will be equal to 0, or x minus 4 will be equal to 0. So this implies if x plus 14 is equal to 0, then we have x is equal to minus 14, and if x minus 4 is equal to 0, we have x equal to 4. So these we are having two solution of x of the equation of the quadratic equation x square plus 10x minus 56 equals to 0. But x is the length of the side of a triangle, it cannot be negative. So this is not possible. So we will have x equals to 4. So if x equals to 4, the question has asked the length of the longest of the perpendicular side. So obviously the longest perpendicular side is BC, which is x plus 10, x is 4, 4 plus 10, this is 14. So 14 centimeter is the length of the longest perpendicular. So the correct choice is B. B is the correct choice. Let's see the last problem, question number 5. The perimeter of a right angled triangle is P and its area is Q. Then the sum of the lengths of the perpendicular sides is, let's say this be the right angled triangle, let's say ABC. Perimeter is given, perimeter and area is given. Okay. The question has asked to find the sum of the lengths of the perpendicular sides. Let's say the length of the perpendicular sides be x and y. X and y. So we have to basically find x plus y. We have to find x plus y. Okay. Now, what do we know? We know area, which is given as which is q. Area of the triangle is given as q. So q will be equal to half into the product of the two perpendicular sides. So xy by 2. So this implies that xy is equal to twice q. Also we know the perimeter is P. So we know the perimeter is P. Okay. Mm. Now what will be the length of perimeter is P. If perimeter is P, then the hypotenuse will be P minus of x plus y. P minus of x plus y. Okay. Now, okay. We have to find the value of x plus y. Okay. Now, using the Pythagoras theorem, we know that AC square will be equal to AB square plus BC square. So, this implies, let's say, I am assuming x plus y to be z. We have to find the value of x plus y. So, I am assuming let x plus y be equal to z. So, we have to find the value of z. So, what is AC then? AC is P minus z. P minus z square is equal to AB square x square plus y square. Okay. This is equal to x square plus y square is equal to, I can say, x plus y whole square minus twice xy. Now x plus y we have assumed to be z. So this is z square minus 2xy. Xy we know is 2q. So this is 2q. Okay. Now if I expand p minus q, p minus z square, in the left hand, on the left hand side I have p square plus z square minus twice pz is equal to z square minus 4q. Z square cancels out from the LHS and RHS. So we have, we can say twice pz is equal to p square plus 4q. So this implies z is equal to p square plus 4q divided by twice p. So p square plus 4q divided by 2p should be the length of the length of the sum of the two perpendicular sides. So the correct choice is C. C is the correct choice. So with this, it comes to an end in solving set 3 of 5 illustrative problems based on the concept of area and perimeter of triangles that I have discussed in part 3 video. I hope this video will be beneficial to you to how to apply the concept of area and perimeter of different types of triangles to solve this kind of problems. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think in the next video, maybe I will solve one more set of 5 problems, and then I will move on to the topic of discussing area and perimeter of quadrilaterals. So please stay tuned for the upcoming videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.